So this next section, we deal with this. So last time what we dealt with was just kind of getting acquainted with the vocabulary, the notation, and that sort of thing for sequences and series. We talked about indices, they're like counters. We talked about formulas. We talked a little bit about arithmetic and geometric series. We talked about how you can write those things down. We talked about sigma notation, the fact that it sums up or it adds the terms. We said they're finite, they're infinite. It depends on what it is. And we went through a couple of formulas that allow us to find the sums of some particular types of series. Okay, so we just kind of got acquainted with that. And if you got done with that, then you're probably in pretty good shape for understanding this section, because this section is all about one specific type of sequence and series. Okay, it's called an arithmetic sequence and series. Now, the word looks like arithmetic. It's pronounced slightly differently. Arithmetic is a noun. Okay. And arithmetic is an adjective. Okay. Did you do the arithmetic? It was very arithmetic. Okay. Arithmetic is an adjective. Okay. So that's how that's said. So there are two very common types of sequences and series. Okay. They're very easy to work with. The first one is arithmetic. Okay. Arithmetic. And the other one is geometric. Geometric. Okay, so we've got arithmetic and geometric, and there's some really nice patterns that we can catch for each of them. And if you understand arithmetic sequences and series, which is what we're going to cover today, then tomorrow when we cover the last section that we have to cover in Math 1050, it's on geometric sequences and series. And if you understand today's stuff, tomorrow's stuff is going to be that much better. Okay, let me get rid of this right here. Test is a week from Tuesday. Week from tomorrow. Okay.
I was like going to hit myself up this week.
Okay. So arithmetic sequences have what we call a common. Please pay attention. They have what we call a common difference in between each pair of terms. And if you have a geometric sequence, then you have a common ratio between each pair of terms. And basically what it comes down to is we're going to figure out how we get from one term to the next. How we get from one term to the next. What operation do we use to get from one term to the next? That's going to determine whether it's arithmetic or geometric. Okay? So in this first example, it says determine whether each sequence is arithmetic or geometric. I'm telling you it's one or the other. And it says notice how many common differences or common ratios there are between the first term and the nth term. So here's how we'd look at this. Now clearly if I start off with 5, and they both start off with 5, and then go to 8, 11, 14, 17, that's enough that you can spot the pattern. What's the next one in line? 20, then 23, then 26, and so forth. Okay, so spotting that pattern is pretty easy. Okay, if we start right here, 5, then 15, then 45, then 135, then 405. Now that pattern, spit it out right. You can spot that pattern pretty easily. Okay, what would the next one be? Okay, the next one would be 12, 15. It's a little harder to get because how are we going from one term to the next in this first example? Okay, we're adding 3. So we are adding 3 from one term to get to the next term. And how about in this one? We're timesing by 3. Okay, and that's really the big difference. Okay, if you're going from one term to the next by just adding or adding a negative, which would be subtracting, getting smaller by the same amount every time, that's going to be an arithmetic sequence. If we're multiplying by 3, or say we were dividing by 2, which would be the same as multiplying by a half, then that's going to be geometric. Okay? Now, what I'd like to point out is this. So I'm going to zoom in on this just a little bit. Okay? This is the first term. So this is a sub 1. This is a sub 2, a sub 3, a sub 4, and a sub 5. Okay? What do you have to add to 5 to get to 8? You got to add 3. Okay? Now, to go from 8 to 11, you have to add 3 again, right? We already established that. What I'd like you to notice is how much do you have to add to 5 to get to 11? You have to add 6. Well, that's 2 of our common differences of 3. Okay, how much do you have to add to 5 to get to 14? You have to add 9, or that's 3 common differences. That's 3 3s. That's 2 3s, that's 1 3. Okay, So how many common differences, how many 3's do you have to add to 5 to get to 17? You have to add 4 of them, you have to add 12, right? Does that make sense? Okay. All right, so this is arithmetic. Okay. And the common difference is 3. We're going up by 3 every single time. Okay? Now on this one, again, I want you to take note. If this is a sub 1, this is a sub 2, this is a sub 3, a sub 4, and a sub 5, what do we have to multiply by to go from 5 to 15? We're going to have to multiply by 3. Okay? Now, what do I have to multiply by to get to... You have to multiply by 9. Well, let's see. That's actually 3 squared, right? So 6 was 2 times 3, okay? What would I have to multiply to get from 5 to 135? Okay, it's going to be 27, or that would be 3 cubed, okay? So there are 3 common ratios between the first and the fourth one, 2 common ratios between here and here, and only 1 common ratio between here and here. Okay, let me do this again up here on the arithmetic one. To go from the first one to the fourth one, there are 3 common differences, 2 common differences, and then only 1 common difference right there. Okay? All right, now you can spot that by looking at the terms, but you can also figure it out using a little formula, and this is going to come in handy. So even though this looks like, my gosh, why would we make it this difficult? This actually can come in handy, okay? So to find the common difference, take any term and subtract the one before it. So on this example right here, I'm going to take a sub 3 and I'm going to subtract a sub 1. Or sorry, the one right before it would be a sub 2. So take any term and subtract the one before it. So the common difference should be, if I plug in a 3 right here and plug in a 3 right here, that's the third term minus the second term. Well, the third term here is 11. The second term is 8, and what do I get? I get 3, which was the common difference. Pick any other combination of terms that are right next to each other. So let's take the fifth term and subtract the fourth term. The fifth term is 17, subtract the fourth term, which is 14, I get 3. Okay, the reason we call it a common difference is it's the same difference for every one of those pairs. Okay, so if we have things in common, we have things that are the same. So they have the same difference in between each one of these. Okay, now this is a huge difference. If we want to find the common difference, we take any 2 terms and we subtract the one before it. Okay, so take any term you want, subtract the one before it. If you want to find the common ratio, okay, the word ratio, difference kind of means we subtract. Ratio, what would we do there? We're going to divide them. So take any term and divide it by the one before it. So I'm going to take the fourth term and I'm going to divide it by the third term. Now, notice what happens here. Everybody watch, please. Notice right over here where we're talking about the indices. If I put a 4 right here, n is 4. That makes that n of 4. So I have 4 minus 1. That makes this an a sub 3. So again, take any term, divide it by the one before it. That's what this notation means. Take any term, subtract the one before it. Take any term, divide the one before it. And let's see what we end up with here. This would be 135 divided by 45, and that's 3. The ratio is 3. If I do the same thing with the second one and divide it by the first one, 15 divided by 5, I end up with 3. So I can take any one, divide it by the one before it, I get exactly the same ratio. The ratio is 3, so that's why it has a common ratio. Okay, they all have exactly the same ratio. Now, what if I multiplied by 3 to get between these two and then multiplied by 7 to get to the next two? Would that be geometric? No, it has to be the same difference every single time. Okay? Any questions there? Okay, a couple things we want to point out. Remember, common means the same. The difference or the ratio between any 2 pairs of terms has to be the same in order for it to be a common difference. Okay? And if you think about it, each one of these terms could be adjusted to make a recursive definition, or in other words, a recursion formula, the way this book says it. So this would be a sub n would equal d plus a sub n minus 1. That would be a recursion definition for an arithmetic sequence. And on this one, I'd have a sub n equals r times a sub n minus 1. That would be a recursion definition. Again, recursion definitions aren't the greatest thing to work with. They're a little bit of a pain, but they can come in handy. So it is kind of nice to use them every once in a while. Okay, any questions? Okay, so let's take a look at that next little line there. It says, if the sequence doesn't have a common difference or a common ratio, then it is blank, arithmetic, or geometric. Neither. Okay? So there are lots of them that don't fall into these categories. These are the only ones that we really study in depth in these sections in this chapter. These are the only ones that we're interested in 1050 because they're the most useful, generally speaking. Okay? At least for the time being. All right? Especially geometric. Arithmetic are pretty cool, but we get into the next section, geometric ones come up a lot. So 9.2 deals only with arithmetic sequences and series. Okay? So that's all we're interested in. Now, there are a couple of formulas that you're going to want to be aware of. They're right here. I put them in these boxes. So the first one is a general formula for an arithmetic sequence or an nth term formula. So this is the nth term. What's a sub 1 mean? First term. Okay, so this is the first term. N is just the index. And D, what do you suppose D stands for? Common difference. It's the common difference. Now, I have a little phrase that I use to remember this, and if you'll remember this, I think it will help you a lot. The nth term formula is just this. It's the first term plus n minus 1 common differences. It's the first term plus n minus 1 common differences. And to kind of illustrate that, I'm going to come back and look at this one right here. So let's say I wanted the second term. If I want the second term right here, I start with the first term and I add how many common differences? Just one, because I want to go from the first term to the second term. So that's 1, and we already figured out the common difference was 3, right? So there's our answer of 8. Well, what if I wanted to go to the fourth term? I've got to have 1, 2, 3 common differences. So if I'm on the fourth one, I need one less common difference. So this is going to be 3 times 3. So that's going to be 5 plus 9. There's our 14 for the fourth term. Notice again, first term plus whatever term you're on, subtract one common difference. So if I want to get to the fifth one, how many common differences are there? 4. 1, 2, 3, 4 common differences to get there. So if I wanted to go from the first term to the 20th term, how many common differences? 19 common differences. Okay? So that's why this formula works out the way that it does. Okay? So the nth term formula is the first term plus n minus 1 common differences. There's the first term. There is n minus 1 common differences. Does that make sense? Okay, so please know that. I think the phrase is pretty easy to remember also. We're also going to be interested in finding the sum of the first n terms of an arithmetic series. And this looks like this. S sub n, what do you suppose S stands for? Sum. So sum of first n terms. Okay? What do you suppose n is? It's the index. A sub 1, we already talked about this. It's the first term. Now, if we're adding up the first n terms, the last term is the nth term. That's this guy right here. That is the nth term. This is the last term. So if you take a good look at this, if you want to add these up, you take the first term, you take the last term, and you multiply it by the number of terms we're adding up divided by 2. Now, if you think about this for just a second, we're going to do a problem in just a few minutes that's very similar to one that we did before, and it uses this formula right here. That little one that Carl Friedrich Gauss figured out, that's basically this formula. And the cool thing is it doesn't just work for integers, it works for any arithmetic series. Okay? So the first thing that you're going to need to be able to do is you're going to need to be able to find a general formula or an nth term formula for an arithmetic sequence. Now, if you know this formula right here, or you know the phrase that I just told you you ought to know, then it's pretty darn easy. So it says find an nth term formula for the arithmetic sequence and then find the 101st term. So what you need is, listen very carefully, you need the first term and you need to know the common difference. That's it. Let me say that again. Everybody listening? Remember how I've said what two things do you need to find the equation of a line? Everybody knows you need a point and a slope. Same type of thing here. If you'll keep this in mind, it's going to make a lot of things easier. So you need the first term and you need to know the common difference. Do we know the first term? If they didn't put a subscript on it, it's a sub 1. It is the first term. So that right there is the first term. That's the common difference. Okay? So watch please. Don't write anything down. The nth term is the first term plus n minus 1 common differences. The nth term is the first term plus n minus 1 common differences. They told us the first term was -2. They told us the common difference was 3. There's our formula right there. Now, very seldom do you see it written like this. We normally clean it up just a little bit. So what we're going to do is we're going to distribute through. So a sub n would be -2 plus, this would be 3n minus 3. I'm going to put the two of those together, and it's a sub n equals -5 plus 3n, if you want to write it that way. If your neighbor writes it as 3n minus 5, that's totally okay. Either one of those is acceptable. Okay, now, that's one of the two basic approaches. There's another approach that would be this. Well, let's just write it out and see if we can figure it out. If the first term is -2 and then the common difference is 3, the next one's going to be, well, add 3, that would be 1. Add 3, that would be 4. Add 3, that would be 7. Add 3, that would be 10, and so forth. No. Okay? This is just to figure out what the formula is. That's the first one, that's the second one, that's the third one, that's the fourth one, that's the fifth one. Now, the trouble with doing this is you could look at that for a little while and say, wait a minute, how am I going to figure out where to start? Well, I can see that I go up by 3 every time, right? I mean, you can see that, but they told us that to begin with, okay? So if you get stuck on, you know what, we learned last time how we could write these out and come up with formulas, that's okay, but if you want to figure out a formula that works to figure out a relationship between 1 and -2 and 2 and 1 and 3 and 4 and 4 and 7 that works every single time, that'd be fine, okay? It does get to be a bit of a pain. That's why the formula is so nice, okay? So you could write out the first several terms, find a formula by noticing how many common differences are between the first term and the nth term. If you were going to do this, this would be the easiest thing to do. Again, going back to the way we came up with that formula. Here's the first term, add 3. Here's the first term, add 2 times 3. Here's the fourth term, add 3 times 3. So the first term's -2, and then you're going to add n minus 1 common differences of 3. Okay? I mean, you kind of get to the same place either way. Okay? Again, we're getting to a point in math where if you try and think your way to the answer, in the long run, you're going to run into more difficulty. Okay? So let's take a look at the next one. First term is 5, what didn't I do? We want to find the 101st term. Look how easy it is to find the 101st term. Plug in a 101, that's 303. Subtract 5, so that's going to be 298. Okay, you ready? Okay, I want you to watch again. If you need to write down the formula, the nth term formula for an arithmetic sequence, everybody watching? Watch up here. That literally means nth term. It's the nth term is going to be the first term, which is 5 plus n minus 1 common differences. Now, because that's a -2 for a common difference, I'm going to put that in parentheses. That's the formula. All we need to do is just rearrange it a little bit. So I'm going to distribute through. So that's going to be 5 minus 2n plus 2. So that's going to give me a sub n equals, this is going to be 2n plus 7. Now, it might not be a bad idea to plug in a 1 and make sure it starts in the right place. If you plug in a 1, do you get a 5? Yeah, so it starts in the right place. We have the correct common difference. We want the 101st term. So that's going to be negative 202 plus 7, so negative 195. Okay, are there any questions? Okay, there are a couple problems where you're asked to figure out what the common difference is. You can do this a couple of different ways. You can write out the first couple of terms and just look at it. You can use the formula that we talked about earlier, or you might be able to notice something else. So if I were to write out the first couple of terms, so here's a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, plug in a 1, negative 4, negative 3, negative 2, negative 1, 0. Okay, what's the common difference? How much is it changing every time? And we're going this direction. We're going from the first one forward. We're adding 1 every time, right? So the common difference is 1. You could also do this. There's that formula that says the difference is the nth one minus the n, or whoops, yeah, it is minus. I'm thinking ahead here. Minus the n minus 1. It's just the difference between any two sets of terms. Well, if you take any two of these and subtract or take any one of them, subtract the one before it, that will give you the common difference, but you can do it this way. This is n minus 5 minus the one right before it, which would be n minus 1 minus 5. Now that looks really silly, but watch what happens. This is n minus 5 minus n plus 1 plus 5. And look what happens. Those cancel. Those cancel. Whoops. And we're left with a 1. So there's our common difference of 1. Okay. I'm going to do this one that way. So watch. The common difference should be the nth one minus the n minus 1 term, the one right before it. So this is going to be 3n minus 2 minus 3n minus 1. Oops, minus 2. I understand that, but what did I say just a second ago? If you rely on writing things down and figuring them out and not using the formulas, in the long run you're going to be hurting, especially if you go on past this class. Okay? So take my word for it. So this is 3n minus 2. This is 3n minus 3. So that's going to be minus 3n plus 3. And then this is going to be a plus 2. Cancel here and here. Cancel there. What's the common difference? Common difference is 3. Sure. So we're going to take the nth one, which is this one right here, and subtract the one right before it, which is the same formula, just with an n minus 1 plugged in. So this is negative 2n plus 1. This is going to be plus 2n. This is going to be minus 2. And this is going to be minus 1. Going to work this way every time. Everything's going to cancel except for one number, so there's our common difference. If you wanted to write several of them out, the first one is negative 1. What's the next one? Negative 3, then negative 5, then negative 7, and you can see every single time what's happening. No, it's not going up.
Going down by negative 2.
It's going down, okay? So common difference would be negative 2, okay? Any questions? Okay, does anybody see an easier way where we could just look at this? Tell what the answer is? Yeah. The coefficient in front of the n, okay? Listen very carefully, okay? Arithmetic sequences are produced by linear functions. Arithmetic sequences are produced by linear functions. Linear functions means it has a plain old n. No n squareds, no dividing by n, no square roots of n or anything weird like that. Just plain old n's plus or minus some other number. So whatever the coefficient is in front, that's the common difference. So it's -2 here. What's the common difference on this one? +3. And what is it here? +1. Okay? So that's one way that you can spot it. They have to be linear functions though. Okay? All right, go ahead and flip the page over and now we'll get to some interesting problems here. Okay, you are going to run into problems where they ask you to figure out a question where you think, well, they didn't give me enough information to figure this out. It says, what is the 80th term of that sequence? Well, the pattern's easy to spot, right? It has a difference of 2. We could just continue listing those out until we get to the 80th one. If it was the 800th one, we wouldn't want to do that. So we want to figure out an nth term formula. We want to figure out a general formula. So the formula is, the nth term is the first one. Do we know the first one? Yep. -1 plus n minus 1 common differences. Now, they didn't say what the common difference was, but what is it? You can tell by looking at it. +2. Okay? So if you want to leave the formula like this, I suppose that would be okay. I kind of like them like that, okay, because it reminds us where it comes from. If you wanted to change this and say, well, let's see, this is -1 plus 2n minus 2. So this is going to be 2n minus 3. If you want to write it like that, that's fine. But what we're really interested in is the 80th term. So that's going to be 2 times 80 minus 3. So that's going to be 157. Do you want to know the quickest way to do it? Again, it relies on knowing how these work. How many common differences would there be between the first one and the 80th one? There'd be 79. So you take -1, add 79 common differences, and common difference is 2. So 2 times 79 would be 158. Subtract 1, 157. Yeah, it's plugging in the specific idea. Yeah, it's the same thing. Oh my gosh. Okay, let's pause for just a second.
I don't see the difference of those two. Sorry, that's what I was trying to say, is I don't see the difference of those two.
Okay, on this one we use the formula.
I used the formula, but I got back the second one.
You plugged in an 80 right here, right? Yeah. Okay, you didn't do this. Okay, this is a little cleaner formula, is it not? Okay, and all we did here was, we didn't even think about this. We just said, hey, take the first one. How many common differences does it take to get to the 80th one? 79. So we're going to do 79 common differences. We didn't even think about the formula right there. I'm trying to give you as many tools as possible to understand this, okay? Because the more you understand this, the more you're going to be able to do very difficult problems. And then tomorrow you're not going to come and say, hey, I don't get how to do that story problem. You're going to understand this inside out and backwards. You're also, let me finish, you're also going to remember, hey, Lois said we really ought to know how to use those formulas. So I'm going to get those memorized and make sure I understand those. There are many times where it's much more advantageous to use a formula. This is a piece of cake, just thinking your way to the answer like this, but that way is not always going to work. Or it's going to take so much mental energy to figure it out just plowing through in your mind that you could have done 20 problems like that with the formula, okay?
Where's the -3 come from?
Hang on a second, Marissa.
But that's just using the formula.
No, it's using the idea, okay? I didn't.
No,
Okay.
I used the formula. That's what I don't get.
Listen, stop. The formula is, or the idea is, you take the first term and you add n minus 1 common differences. It's the phrase, okay? Find the phrase in the book. It's not there. Okay, find that phrase right there.
Write down 80 minus 20 years from now.
That's the point.
He's just skipping writing the formula.
That's the
He's
point.
already mentally plugged it in and condensed it.
Yeah, but do you have to write the formula?
Not unless it says to.
No, like the way you have it.
This one?
2n minus 3. No, the 2n minus
This
3.
one? No. Okay, it depends on the problem. Okay?
Okay.
If they say write the formula, either one of these is fine. Which one's the simplest? This one right here. Okay? This is the best way to think of the formula. And if all it says is figure out what was this one, the 80th term, that's the easiest way to go straight to the 80th term without writing down any formulas. Okay?
I got it now.
So when would you use the 2n minus 3?
Whatever you want.
This is what the back of the book's going to say. It's not going to say this. Because it's simplified. You're not going to find 10/6 as an answer in the back of the book. You're going to find 5/3.
I figured that out.
Good. Good.
So you just need to know how to get that just for the back of the book if you want to check your answer.
Absolutely. The thing I like about this is this contains the whole idea. Okay? It's not like you have to sit. So watch. If I said, hey, just memorize this and use that all the time, that's not very satisfying. Okay? If you understand why this works the way it does, you don't memorize anymore. You just understand how it works. Okay? And those are both very valuable. You want to understand the formulas. You don't want to, when we get to really complicated problems, you don't want to just be, I don't have any idea why this formula works, I'm just going to use it. You'd want to understand it, but then you're going to rely on the formula to do the work that it does. Okay? Most people like the quadratic formula, even though they don't remember how to derive it. Okay? You've seen it enough, you've used it enough, you just trust it. Okay? I'm trying to make sure you understand this inside out and backwards, because then you're going to be able to solve some very difficult problems. Good? Okay. All right, so let's take a look at the next one. Okay, so this is what I'm talking about. On some of these problems, again, I'm going to solve this two different ways. You could spend time thinking your way to the answer. Okay? Or you can rely on the formulas, depending on who you are and what you like to do. Both are very valuable. What would be really nice is if you could do both. So this one says, find an nth term formula. Notice it doesn't say find the 80th or anything like that. It just says find an nth term formula. And here's what it tells you. It tells you the fourth term is 3. The 20th term is 35. And that's it. And you have to come up with an nth term formula. Now, in order to make an nth term formula, you need to know the first term. And you need to know the common difference.
We don't have either of those.
You don't have either one of those. Okay?
Yeah, can we just write that in the question?
What's that? What'd you say?
Can't we find them?
Sure. Absolutely we can find them. And we find them using the idea, using the formula. If I'm on the fourth term, I must have taken the first term and then added how many common differences? 3. If I'm on the 20th term, I must have taken the first term and added how many common differences? 19 common differences. Are you with me?
Why did you get the
Oh. If you're on the 20th one and you started at the first one, it took you 19 common differences to get there.
Sorry.
Okay? Haven't used those yet. Everybody okay with that? Isn't this the idea behind what an arithmetic sequence does? Now watch. What is the fourth term? 3. So 3 should be equal to the first term plus 3 common differences. What is the 20th term? 35. So 35 should be the first term plus 19 common differences. Now, don't ask any questions past. Do you understand how to get here? Do you understand what we did? Once we get to here, ignore the problem. What is this? It's a system of equations, and all I have to do is solve this by elimination. So I'm going to do -3, -a, -3d, and I end up with 32 on this side, and I end up with 16d on this side. So what's d? D is 2. If I know what d is, then I can come back here and I can plug into this. Whoops, plug into that right there. And I get 3 equals a plus 3 times 2. Move that to the other side, so I get a equals -3. Now, am I done with the problem?
No, we have to put it in the formula.
You're right. So that is the nth term is the first term, which is negative 3 plus n minus 1 common differences, and the common difference is 2. Now, like I said a second ago, and this is why I put these in dotted lines, you will not find that formula in the back of the book. I like this formula because it contains the idea. Look at it. That's the first term sitting right there. That's the common difference. And you can see that to get from the nth term, from the n minus 1 term to the nth term, you've got to do, or first term to the nth term, you have to do n minus 1 common differences. Okay? Now, what you're going to see in the back of the book would be this. Negative 3 plus 2n minus 2. It's going to be a sub n, 2n minus 5. That is what you'd see in the back of the book. What?
It's okay if we do negative 5 plus 2n, correct?
Sure. Yep, that's fine. Okay, this is the same type of problem. Do you want to see a different way to do it?
Yeah.
Depends on if
It is easier.
Yeah. Is it valid or are you going to get mad at me?
No, it's perfectly valid. Okay, but I'd like you to tell me why this works. Okay,
Thinking.
very good. It is thinking. That would be the answer to every question in here. Thank you. Okay. If you're on the 9th term and you go to the 30th term, how many common differences are there between the 9th term and the 30th term? There are 21 common differences, right?
Yeah.
So the difference between the 9th one and the 30th one is going to be 21 common differences. Well, how far is it between those actual numbers? 74 minus 11. 74 minus 11 is 63. Well, lo and behold, look at that. D equals 3. Okay, now watch. The 9th one is the first one, plus 8 common differences. The 30th one is the first one plus 29 common differences. So if we solved it the same way we did above, you'd have 11 equals a plus 8d. You'd have 74 equals a plus 29d. So if I do that little elimination technique again, I get 63 over here, and I get 21d over here. Okay, it's skipping from the system of equations right to here. Now, that is a shortcut. Shortcuts usually have a pitfall. Does anybody know what it is? Especially if I erase all of this. You don't know A. And you don't have a formula to plug A into. Unless you think about it for just a second.
But you kind of do, because if you do everything, you just erase it, you didn't erase it. All you need to do is find one of them and plug D in.
That's right. Okay. So do you have to write at least some of that system of equations down no matter what? You do. So let's say the 9th term is the first term plus how many common differences? 8 common differences. You can't get away from that idea. There's no getting around it. Okay? So this is going to be 11 equals a plus 8 times 3. So that's going to be negative 13. Is that right?
Yeah.
Okay? So that gives me D and that gives me A. So the nth one is the first one, negative 13 plus n minus 1 common differences of 3. So I'll distribute through. So the nth one is going to be negative 16 plus 3n. Tylen, is it okay if I wrote it that way?
Yes.
Thank
That's
you.
how I wrote it.
Good. Questions? Okay. Here's that other formula right there. We're now going to talk about sums. If you want to add up the first n terms, listen carefully. If you want to add up the first n terms, you need 3 pieces of information. If you want to find the nth term, you only had to have 2 pieces of information, the first term and the common difference. If you want to add up the first n terms, you need to know n. You need to know how many terms there are. If you want to write that down somewhere, that wouldn't be a bad idea, especially on the back. How many terms there are. What's the first term and what's the last term? Because that's the structure of this little formula. First term plus the last term times the number of terms divided by 2. First term plus the last term times the number of terms divided by 2.
Hey, that's like when we did the 1,000.
Yes, it is. It's exactly like it. Okay? The cool thing is this works either way. So, do I have the first term? I do. So there's A. Do I have the last term? Okay, so here's the problem. I can put a 1 underneath that, but I don't know which term this is. So what we have to do is we have to figure out a formula. The formula for this is A sub n is equal to
And number 2.
2n minus 1 if we figured out what it is. So everybody see the common difference is 2? Common difference would be 2, right? Okay. So since that common difference is 2, if I plug in a 1, I end up with a 1. If I plug in a 2, I end up with a 3. There's the right term. Now, what I need to know is, which one is this? So set 59 equal to 2n minus 1. Move the 1 over. That's a 60. N equals 30. So how many terms are there? There are 30. Okay? So what 3 things did we need again?
The index.
Number of terms, first term and last term. So the sum of the first 30 terms is 30 divided by 2, and then the first one plus the last one. And that's it. So this is going to be 15 times 60. So if you multiply those together, that's 900, isn't it? Answer's 900. Okay, watch. That has all numbers. The only thing that was hard about that, the only thing that was missing was we didn't know how many terms there were. Now that's a short enough list that you could go through and count. Okay? We could have figured out that was the 30th one just by writing them out and counting. But if that had said, 597, you probably would want to figure out, you'd want to figure out a formula so you could figure out what term you were on. Okay? Do we have the first term? We do. Do we have the last term?
Well, we do. It's infinite.
It's not infinite. It's a number that came out by plugging in the last n, the last number that we needed to plug in. So here's the first term, here's the last term, and we have n terms. So what's going to screw some people up on this is they're going to look at it and they're going to say, I don't know what n is. Okay, this is going to produce a formula, not a number answer, and that's unnerving for some people. So the sum of the first n terms, notice that's the first term, that's the second term, that's the third term. Does this little formula right here, does 2n produce that? It does, okay? So we're going to do n over 2. First term is 2, last term is 2n, and could we clean this up at all? We could. Factor out of 2, you end up with n times, I'll write it this way just so we're clear. That is your answer. It's a formula that tells you, hey, if you've got this sequence of even numbers, you tell me how many even numbers you want to add and I'll give you the answer. So what if you wanted to add up the first 200 even numbers? So in other words, stop at the 200th term. What are you plugging in for n? 200. 200 times 201. That's it. Okay? Let's take a look at this one. Start at 1, 2, 3, 4, 5, ... all the way to, where am I going to stop? Stop at 100. Okay, 100 on this one. Do I know the first term? Yep. Do I know the last term? Yep. Do you know how many terms? 100 of them, divide it by 2. So there's 50 times 101. So that's going to be, let's see, is that 50/50? Is that what that is? Okay. 5,050. Again, number answer on 2 of these because they gave us all the information that we needed. Let's take a look at this one. We want to find the sum of the first n terms. That is the nth term. That's what they got by plugging in n. So, how many terms? N of them. Divide it by 2. Do I have the first term? Yes. Do I have the last term? Yes. Simplify a little bit. The 1's go away. Once the 1's are gone, the 2's cancel, and lo and behold, what do I get? I get n squared. Take a good look at this. This is a little bit surprising. If you want to add up the first n odd integers, the answer is n squared. So if I want to add up the first 15 odd integers, if I want to add 1 plus 3 plus 5 plus 7 plus 9, until I get to 15 odd integers, I just take 15 and square it. They'll add up to 225. Done. End of story. If you want to add up the first 4,000 odd integers, you don't have to write out all 4,000 of them. You don't have to find some funky pattern. We just figured out, you know what? If you want to add up the first n odd integers, it's n squared. Lots of time saving here. Okay, let's take a look at the next one. This is a story problem. This is the last one that we'll do. Let's see, maybe we'll do this one right here. That one's not bad. They used to allow you to use graphing calculators. You can do some really cool stuff with that, like you can put in some commands that will add them up for you. You'd have to know what they do. You'd have to know where to find them and what to put in where. But here's a story problem, and this is one where you want to think. We've got this story problem here where it's got to come from an arithmetic sequence or series somehow. It's in this section. And it says the corner section of a football stadium has 15 seats in the first row and 40 rows in all. So the first row has 15 seats and it's got 40 rows in all. So we've got 40 rows here altogether. Okay? And it says each successive row contains 2 additional seats. How many seats are in this section? So say you got to go through and paint them, redo them, or whatever it happens to be. You don't want to go through and count every one of them. You want to figure it out in a fairly quick fashion. So we're going to be adding all of these up. So we need the sum formula. Again, the sum formula was you needed to know how many you had, how many terms, divide that by 2, and you needed the first one, and again, sometimes they just put an A, and then the last one. Now, do we know how many terms?
Yeah.
Do we know how many terms? What's the equivalent for a term in this problem? Rows. Do we know how many rows? We do. Okay? We're going to add up the first 40 rows. 40 rows divided by 2. Do we know how many there are in the first row? Do we know the first term? 15. Here's what we don't know. We don't know how many there are in the last row. Now, do we have to come up with a formula to produce all of them, or can I say this? You know what? I want to know how many there are in the 40th row. Well, let's see. That formula said I take the first term, or the first, in this case, row. How many are there in the first row? 15. Plus n minus 1 common differences. Well, to go from the first one to the 40th one, how many common differences? 39. And what is the common difference? How many more in each row? 2. So if I multiply those together, I get 15 plus 78. So I end up with 93 seats in that last row. So this last corner here, it's a really long row, 93 seats there. Hope the person in the middle doesn't have to get up and go to the bathroom halfway through. Where do I put that?
In that blank space that you left.
Right here. Now the cool thing is, when I first saw this formula, I thought, well, wait a minute. Every single time we're going to be dividing by 2, that's not going to work out all the time. We're going to have some fraction. That doesn't make any sense. You're not going to have a fraction, okay? Because either this is going to be an even number of terms, and you're going to be able to cancel there, or these are going to add up to an even number. So you'll always be able to cancel, okay? Assuming they're whole numbers and stuff like that. Okay? So this is going to be 20 times. Add these together. This is 108. Am I right about that?
Yeah.
Multiply those all together. So we have
2160.
21,060. Any questions? 2160. 2160. Okay. All right. Just to make sure we're clear, would you find the answer to that one right there? What three things do you need? You need the first term. You need the last term. And how many terms? Do we know how many terms? How many? 90. So 90 divided by 2. First term. Plug in a 1, you get a 1. Last term. Plug in a 90, you get negative 177. So this is going to be 45 times negative 176. Is that right? Is it okay for the answer to be negative?
Yeah.
Absolutely. And what is it in this case?
Negative 79.
7,000? 7,920. Okay. All right. Any questions? All right. We'll finish up the, finish up 1050 tomorrow as far as new material. One more midterm exam, one more final exam. Tomorrow I will give you final review packets so you can get started working on those. Okay? Have a great day. Let's see. Yeah, you should have 9.2 done tomorrow. We'll hand both 9.1 and 9.2 tomorrow at the beginning of class.